All right, so today we're going to take a look at a section on application of trig functions. So there's really going to be no new math, so to speak. It's just going to be applying that math to word problems and different applications that we see. And we're really still going to be focusing on sine, cosine, and tangent. So we want to keep in the back of our mind our SOHCAHTOA. All right, because that's going to help us remember that sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. All right, now today we've got two new vocab words, and it's angle of elevation. All right, so what I want you to think is look straight out ahead of you, all right, and then look up towards the corner of the ceiling. All right, that angle that you raised your eyes from looking straight ahead to looking up at the edge of the ceiling, all right, that's called your angle of elevation. All right, so it's always off of horizontal, and it's an angle up. Now, similarly, if I say angle of depression, that would be if you start by looking straight ahead, then bring your eyes down to the edge of the floor. All right, you're going to lower your eyes there, and that's an angle of depression. All right, so elevation, we raise up, depression, push down. All right, so those are going to be the two things that we're going to remember as far as vocab. We're going to have an angle of elevation or an angle of depression. Now, once we have that, it really just becomes setting up a trig equation very similar to just our rote problems that we did on the quiz. So this example, a surveyor measures the angle of elevation to the top of a volcano to be 8 degrees. All right, so notice we're going up this way, 8 degrees. All right, and the surveyor is 8,500 meters from the volcano. So we're looking at that distance being this side because it's a horizontal distance. All right, and we want to find out how tall the volcano is. So when I look at the three pieces I have an angle, I have opposite and adjacent, which is connected by tangent. All right, so we set up our little trig equation. We'll multiply that 8,500 over, and then we'll take it straight to our calculator. And our least accurate side here was the 8,500 meters, so that's what we're going to use for our rounding, is going to be to the nearest whole meter. All right, now, the key thing to remember is that they're always measured off of horizontal. So we're going to take a look at a first example that's blank here for us. It says a blimp is flying 500 feet above the ground. All right, so we'll give ourselves a little blimp there. All right, and it's 500 feet above the ground. All right, so we'll put our units on there too. A person on the ground sees the blimp by looking up at a 25-degree angle. All right, so we have a person over here, and they're going to look up at 25-degree angle, all right, like this. So we know that's 25. All right, it says the person's eye level is 5 feet above the ground. All right, so that means that, you know, the bottom part of this is 5, and then the top part would be 9, 495. Right, because we're taking basically their eye line off the bottom of that. So we have a 25-degree angle, right, from the eye line, so from here, up to this line of sight to the blimp. All right, but there's that extra little 5 feet at the bottom. It says find the horizontal distance from the blimp to the person. All right, so we're going to do opposite over adjacent, because it's this side, and we want to find the horizontal distance, so that side there. So opposite and adjacent. So we're going to say tan of 25 equals 495, because remember we had to subtract off the 5 feet for the height of the person, over adjacent, which is x. So we're going to multiply that x over, so I have x tan 25 equals 495. And then I'm going to divide both sides by tan 25. All right, so at this point we'd have to take it to a calculator and get that typed in. And that will give us the x value. So go ahead, take a second, do that, and I'll do the same. All right, so when we take that to the calculator, we get 1,061.5309. And then we look at our side. The most accurate side was nearest foot. So we're going to round this to the nearest foot, and we have 1,061 feet. Actually, that's a 5, so we're going to round that up. So it's 1,062 feet. All right, and that would be the answer we give. Now, if we look at example 3 here, it says a forest ranger looking out from a ranger station can see a forest fire at a 35-degree angle of depression. So we have a watching tower up here. All right, so we have a ranger standing up there. All right, the ranger is looking down, all right, over here to a fire. And it says that the angle of depression is 35. So we got to remember that's always off a horizontal. So we're going to measure down there in 35 degrees. All right, it says 100 feet above the ground is what we're looking from. So we got 100. All right, and it asks how far is the ranger station from the fire. So to me, I read that as the horizontal distance down here. All right, usually if they want the hypotenuse of this, they're going to say things like the line of sight distance rather than just the distance. So when they say just the distance, we're going to assume horizontal. If they say line of sight, that's when we're going to go from like eyeballs to object and measure that way. So now on this one, we might feel like the 35 is in a bad spot for us. So one thing we can do is we know we have two parallel lines. All right, this dashed line at the top and the solid line at the bottom. So I can bring that 35 degrees down here. All right, so an angle of depression from above is the same as an angle of elevation from below. All right, so if I go to the fire and I look up, angle of elevation 35. If I go to the top of the station, look down, angle of depression is 35, would be the same line of sight. All right, so from the 35, once I've moved down here, it's a little easier for me to see. I've got opposite and adjacent, so tan 35 equals 100 over x. Kick the x over, x tan 35 equals 100. We'll divide by the tan 35. So I've got 100 divided by tan 35, right, which would give us a 142.8148. All right, for the x. And I look, the best I've got is to the nearest foot. So I'm going to take that again. So I've got 143 feet. All right, and that would be my answer. All right, so that's two examples looking with a single triangle in each. All right, if I look at the next one, it says a blimp flying over a football game. The pilot sights the stadium at a 7-degree angle of depression. All right, so we got a blimp up here again, 7-degree angle of depression. All right, so off horizontal, we have 7 degrees up there. It says the blimp is flying at an altitude of 400 meters. All right, so we got 400 meters there. Over here is our stadium. All right, and we want to find out, all right, as I do this, let's see, how many meters does the blimp need to travel to be over the stadium? So we want to find this side down here again. All right, so the 7-degree angle of depression is the same as the 7-degree angle of elevation from the other side. So we've got another opposite and adjacent, so tan of 7 degrees equals 400 over x. Kick the x over, so x tan 7 degrees equals 400. We'll divide by tan 7 degrees. All right, and I get x equals, now we need to do 400 divided by tan of 7. All right, and that gives us 3,257.73857. All right, I looked at my picture, and nearest meter is the best I've got, so we've got 3,258 meters, all right, as an answer for this one. All right, so those are 3 examples of the strategy we're going to use on all the word problems. Tonight's homework that you're going to see uses the same strategy, so really lean on the picture to help you out. All right, these are going to be a little bit tricky. Some of them are tougher, some of them are easier. All right, so it's not necessarily in sequential order of easy to difficult. So try each one, bring your questions tomorrow to class, and we'll get them all cleared up. All right, hope that helps. Have a great day. Thanks, bye.